My name is Alistair Routledge. I'm a professor of applied mathematics at the University of Leeds, and today I'm going to talk to you a little bit about binomial series expansions. So the binomial series is a useful general tool to deal with things that look a little bit like 1 plus x to the power of n. So n here could be any number, it doesn't have to be an integer, and x here could represent a larger thing. The key is, and this 1 here, even the 1 doesn't have to be a 1. I'll show you some examples in a moment where that number isn't 1 and how we can deal with that. But the general formula for a binomial expansion of something that looks like this is 1 plus, and then we take nx, plus, and then it is n times n minus 1 divided by 2 factorial times x squared, plus the next one is n minus 1, n minus 2 divided by 3 factorial x cubed. And the general term in the series is, so if we think of it in general, we're going to have x fourth, x fifth, and so on. And if we think of the x to the power of k term, what have we got? Well, it starts the same, n minus 1, n minus 2, all the way down to n minus something, which we can't necessarily remember first off, so let's leave that out for a moment. We know that it's 3 factorial x cubed, so it is k factorial x to the k. And what number is going to be here? Well, it is 1 less. That number there too is 1 less than 3, so it is n minus k minus 1. X to the k, and then and so on. So this is an infinite series if n isn't an integer. You can see that if n is an integer, supposing n were a number like 2, for example, then this term is not 0, this term is not 0, this term is not 0. But if n is 2, then we've got n minus 2 here, which is 0. And so that term would be absent. And all of these other terms have an n minus 2 in them. So all of those other terms will be absent. So if n is an integer, this series stops at some point. And clearly, you know, if n is 2, this is just 1 plus x squared, which is 1 plus 2x plus x squared. So clearly that stops. But if n isn't an integer, this series never stops. And you might ask yourself, well, is it a series that makes sense?